Greetings and welcome, friends. Me and Josh and my other friends are here talking about properties of exponents. This isn't an English video. This is a math video. I'm not a wordamatician. I'm a mathematician. And here I am using the language of math, an international language, perhaps, Josh, to describe for you some of the properties of exponents and how we might simplify expressions. Which actually, speaking of which, simplifying expressions, what are we looking for? We're looking to combine any things that have the same base. We're trying to get rid of any negative exponents. We're trying to get rid of any parentheses if possible. If there are numbers, we're trying to reduce them if they exist within fractions. So here we go. We've got two bases that are being raised to a common power of -5. And so I'm going to distribute this exponent to both of them. Question. No? All right, so I've got 3 to the -5 times s to the 8th, and I could put that to the -5. I wouldn't necessarily write that step, but I just want to make sure you realize that s to the 8th is being raised to the -5th power. So 3 to the -5th, how do I deal with a power raised to a power? Do you guys recall? Multiply the exponents is correct. So 8 times -5 is -40. And how do I deal with negative exponents? Yeah, if they're upstairs in the fraction, you move them downstairs and make their exponents positive. If they're downstairs, you move them upstairs and make them positive. Right? Let's see. Here, Maggie, you should be tracking with me here. So let's see. I've got 3 to the 5th, s to the 40th, and no one's living upstairs, so 1 moves in upstairs. And that is my fraction. Now, 3 to the 5th, they may have asked you to calculate that. What is that, like 243. So maybe Big Ideas was looking for this answer, 1 over 243 s to the 40th. So notice no negative numbers exist. So, this one's interesting. Now, question, this minus sign, is it being raised to an even or an odd exponent? Being raised to a... Is -2 even or odd? It is still even though it's negative. Even though it's negative. So I can actually just ignore that minus sign. A negative number being squared or fourthed or sixthed is going to become positive, right? Jed, you're writing this down, right? You're not just destroying things with the pens that are provided by me? All right, well, let's keep going. Question, comment? I don't think I have any more. But I'll see what I can do during lunch. So let's see. So this is going to be the same as positive w to the 3rd over 6. And this exponent is going to be distributed to both top and bottom, right? Here, Zeb, you should take out your homework as well. Use this time wisely, please, ladies and gentlemen. So let's see, w to the 3rd all to the -2nd, 6 to the -2nd now. I'm going to multiply those exponents. So that's w to the -6th over 6 to the -2nd. And to deal with these, w is going to move downstairs, and 6 is going to move upstairs. Neither of them were happy with their apartments or their living situations, and we're going to swap them. So I'm going to have up top 6 squared over w to the +6th. And 6 squared I could simplify to be 36. These negatives? Right. This became positive because of the even exponent. Correct. Yep. Yeah. So yeah, there's so many little properties, which is going to explain our David Hilbert quote later today. So 36 over w to the 6th is my final answer. I think that's a false accusation against my man Hillbilly Bert. So, all right. Now, right here is a boss fight with just about every single property and skill required when it comes to exponents. So what we're going to do, we're just going to like start picking apart this problem. You could distribute these exponents from the outside to everybody on the inside, or you could start picking apart these things from the inside first before you distribute. There are many possible routes to get the same simplified answer, but similarly, there are many routes to drive from Brattleboro to Wilmington, and as long as each of us drive the speed limit and obey the laws of the road, right, we will all get there safely, in theory, without breaking the law. Okay, so same idea. You could have many different strategies for doing this. So I'm going to deal with these m's first, and I'm dividing two things of the same base, so I'm going to subtract their exponents. So I'm going to have m to the negative 5 minus a negative 2. Careful of that double negative, friendo. Careful, careful. Let's see, n to the 0, what's that? That's just 1. Yeah, so I don't even need to subtract that exponent. That's just 1. So I've simplified this partially. It's still being raised to the second. Maybe you can do some simultaneous steps, but I won't make you risk, don't do anything too crazy. Let's see, can I simplify anything here? The m is, got nothing to combine with, times n to the 4th. I'm going to subtract its exponent, or subtract the denominator's exponent from it. What is n's exponent here? There's an invisible 1, so that's going to be 4 minus 1. So don't assume that it's 0 just because it's invisible. Not. Over 9 all squared. All right. So we're making progress, right? We're picking this boss down, doing some little damage over time, taking it out a little bit slowly, chip away at it, so to speak. So I've got 3 to the 3 times m. Negative 5 plus 2 is negative 3. N squared over 4. And you probably could have gotten there without having to write down this step, but with the double negative and everything, I wanted to make sure we were all on the same page. This one is, that's just n to the 3rd, isn't it? Yeah, I'll write it down. What the heck? So I'll have m times n to the 3rd over 9 all squared. It's just about distributing time. I'm feeling it. Let's start it. So 3 is its own base, m is its own base, n is its own base, and 4 is its own base. Similarly over here, everybody is getting their exponents multiplied by 2. Technically, I could move this m downstairs first if I wanted, but I don't care. Bunch of different routes. So I'm going to have 3 squared, m to the negative 6th, n to the 4th over 4 squared, multiplied by m squared. N to the 3 times 2 is 6, and 9. I'm telling you, this problem's a boss fight for real. Yeah, I gave it to you to make you stronger. Doesn't matter. 3 squared is 9. M, we're going to move downstairs. Ooh. Man, this problem's still going. Yikes. I might end up even having to combine it on the side here. So 9n, all right, to the 4th over m to the 6th. Well, I guess I could do 16m 6th. I'm a fan of writing numbers in front of variables, and you'll find that mathematicians tend to do that. Yep. 9 squared is 81. Okay. So guys, question, how do I multiply fractions? Yeah, you actually just multiply across. I can really just write this as one big fraction where I'm multiplying the tops and the bottoms. All right? So I'm gonna continue up here. Sorry for the notes being all wonky here. So let's see. N to the 4th times n to the 6th. Going to be an n to the 10th when I add those exponents. Now, guys, Ooh, might be ready for this. I'm going to show you a shortcut for these m's here. Now, I could do m to the 2 minus 6 up top. That'll give me a negative, and I'll end up having to move it down to the bottom, right? Another way, so I could have written this as m to the 2 minus 6. I would end up with m to the negative 4, and then I'd move it downstairs, and I'd end up with 1 over m to the 4th. The other strategy you can use, and I'm going to let you guys use this route, is instead of subtracting it from the top, just always subtract the little guy from the big guy. So I'm going to subtract 2 from 6 in the location of the denominator to begin with, okay? And that'll make things a little bit easier. So I'm going to get m to the 6 minus 2 downstairs and get m to the 4th. I'm not done that yet, yeah. So I'm dealing with these m's and n's. I've got between 9 and 81. I'm thinking I can reduce that fraction. What number goes into both of them? 9, yeah. So I'm going to cancel out 9 here. It goes into itself once, and into 81 9 times. And so up top, there's no number with n, just technically an invisible one. Down bottom, I'm going to have 16 times 9. Is that 144? My calculator friends. 16 times 9? Yeah, 144. I was just mostly thinking about 16:9 ratios for televisions. So, n to the 10th over 144, m to the 4th. Brandon, we're trying to learn about problems here. Seems like you might not be. So guys, so notice, this problem, definitely a boss fight. Definitely lots of routes you could have taken. You just keep chipping away at it. All right, so if on the quiz, which there won't be a problem that tough, if you made an error on one part, keep doing the problem, and I'll give you credit based on what you did know. All right, here we go. Scientific notation. So I'm able to divide these things out separately. Okay, I'm going to reduce 6.4 and 1.6 on its own, which, by the way, if you divide those out, I get 4 times. And then how do I deal with dividing two things of the same base? Subtract the exponents. So that's going to be 4 times 10 to the 7 minus 5. And I'll have 4 times 10 to the 2nd. Now, question, is this in scientific notation? Yes, it is. Because there's only, right, you could call it 4.0 if you wanted. There's only one number in front of the decimal. That won't always happen for these problems. Technically, right? Well, they just wanted us to write it in scientific notation. And then it said, okay, you're right. Sorry, my bad. And then it did say standard form. So multiplying 4 times 10 squared, that's the same as 4 times 100, which is just 400. Right? The other way you can think about it is move the decimal place to the right by 2, which also gives you 400. All right? And this last question, near and dear to my heart, probability, which you guys will end up, well, you probably saw some in middle school. Technically, you'll see some more in algebra dose. But these ways that probability get these crazy, massive exponentiation sort of things going on when you're expecting multiple simultaneous events. Oh, it's crazy. The probabilities get pretty small, improbable, infinitesimally small sometimes, quite quickly. So the probability of rolling a 6 on a number cube is 1 out of 6. Agreed. The probability of rolling a 6 twice is 1/6 squared, or 1 out of 36, which is far less likely. All right? Write an expression that represents the probability of rolling a 6 n times in a row. So my answer for part A is it's going to be 1/6 raised to the nth power. So if I want 10 6s in a row, that becomes an incredibly improbable event. And when considering these types of probabilities and the time and scope of the universe, you can actually determine whether or not an event was likely to have occurred in the existence of the universe with all of the matter available and all possible interactions between that matter. And if it's beyond a certain probability bound, you can say, well, it could have happened, but just not in this universe, right? What you would say. So what's the probability of rolling a 6 4 times in a row? That would be 1 over 6 to the 4th, which is 1 to the 4th over 6 to the 4th, which is 1 to the 4th. That's real easy. 1. And 6 to the 4th, what? 1296. So 1 over 296. So that's one way you could write it. If you wanted to have that as like a percent likelihood, I could actually do 1 divided by 1296. And I end up getting like a 0.007% chance of that occurring. So it's unlikely. Yeah. Or no, sorry, 0.07. I counted my decimal places wrong. And then it says, what is the probability of flipping heads on a coin 5 times in a row? So probability of flipping heads 1 time is what? 1/2. 5 times in a row would be 1/2 to the 5th power, which would be 1/5 to the 2/5, which is 1/32. What? Explain it? Oh, explain. Yes, because you would multiply the probabilities of independent events. Multiplying 1/2 by itself 5 times is the same as raising it to the 5th power, right? You done distribute that exponent over the top and bottom. You get 1/32, which is the same as a probability of 3.125% chance, which actually happens to be more likely than rolling 2 6s. Right? 1 divided by 36 was a 2.77 repeating percent chance. So it's actually more likely to flip a coin and get heads 5 times in a row than to roll a 6-sided die and get 2 6s in a row. We're assuming a fair coin where it's 50% both sides. There is an interesting math problem on Numberphile, a YouTube channel, about what are the dimensions. Hi, Avery. Hi. What would the dimensions of a 3-sided coin be? Because technically there's a chance that a coin could land right on its edge. And the question is, how thick would that coin have to be that that cylinder, right, would be equally likely to land on this edge as either of the faces? Which is a weird idea. Oh, maybe I did. There you go. Well, thanks for watching, internet friends. Tienen un día el más bien del mundo.